Yo, what's up, what's up, what's up, what's up, what's up? Welcome back. Today we're working on my terminal emulator. His name is Termy. He's a little bit stupid right now, but we have, we're a couple days in and we have like a basic shell running. So I run this, he opens up a window, we're showing bash of some sort, right? And if I say like ls, it gets something, I say ls color, we get colors, which is pretty cool. I can do like pager equals cat get log n1, and we see like we don't have any like scrolling handle like scrolling implemented, but we do see that like this looks like kind of like a normal get log. What is this? Parse the bold sgrtg. That's not like a word. I probably should have read my commit message back before pushing it, but no biggie. And anyways, where we're at today is the reason that I am typing pager equals cat before running get log is because if I run get log -n1, it gets like kind of fucked up. Before it was crashing, and it's not crashing, which is kind of like a nice little improvement from what we had before, but definitely doesn't look great. And I believe the cause of that, I have to double check this, but I believe it's that when you start up like a random like terminal application that is like something like less, so get log, right? This is like some fancy ass program that like when I press buttons, I'm like scrolling around, but I'm not like actually scrolling around. If I scroll back in my buffer, it's not actually, the content's not back there. And so what it's doing is it's like moving the cursor to all of these like positions and then like punching stuff out there. And you can see we have like a lot of unhandled stuff there. But what I was seeing sometimes was that it would move the cursor forward and it would like crash my application as a result. So let me see if I can like think of an example of how to do that. If we were to like echo something in our terminal, like ASDF, this prints ASDF, and then if I do something like crazy and I say, I'm gonna escape here and I'm gonna give you like super secret terminal codes, and I'm gonna say, go to the like 65th column, and I do that by saying the letter G. The G says move the cursor in this column, and then I write ASDF again. What we see here is we see like ASDF, and then a bunch of empty space, and then like another chunk here. And when I think if I do this in my emulator, I'm pretty sure that just crashes. Let me double check. ASDF 033 open brace. Let's go like 18G ASDF. Yeah, that crashes. And so I know that case can't happen. It didn't happen that last time, but it does happen often. And the problem there is we are kind of storing the way that we're like tracking stuff in general is we have like some contiguous buffer of data, boom, 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 and in here he has like new lines. Sorry, wrong way. \n. New line, and like if we then were to like try to lay this out in 2D, we'd kind of see like this, right? Because we have like this section, then this section. And that's kind of like all we have. This is like a string. And then when we say like move the cursor around, we say, okay, which like position in this buffer makes sense for the cursor to go at. So if they were say go to like row 2, column 3, we'd be like, that's like byte 20, right? That's like here in this linear buffer. But if they then try to write, and then if they try to write something here, we like overwrite the data, and if we hit the end of the buffer, we like expand the buffer if we need to. And that works like fine if you're moving the cursor into somewhere where there's already been data written. But if they try to say move like over here, and we're like, that buffer position like doesn't exist, but like it would be like here or something, or like say it's in the second line, and so we know that like you would have to like maybe like we would try saying like, okay, well the start of the line is here, and so we need to go over like 15 characters in this direction, and then we would like write to the next line, which is like fucking wrong. Like there's a lot of like incorrect behavior here. And so what I think makes sense is trying to like turn this buffer of data into like some form of abstraction where you can like write to arbitrary locations, get reasonable behavior, but while still trying to keep like the nice thing about what we have right now is if I just take this whole buffer and I feed it into the GUI framework and I say like, hey, can you print this please? He prints something sane because he just like iterates over each character in here. He prints them, the new lines get handled correctly, and he's just like done. And so I want to write like some form of like canvas, I'm going to call it. I don't know if that's like a good word for this, but like where hopefully we can keep this constraint where it's actually backed by just like a string. But when we do something like try to write to a position that doesn't make sense, we like automatically handle that in some way. That's what I want to look at. And then I'm kind of hoping that if we do that, then stuff like less might work a little better. It looks like there's also a large chunk of unhandled codes. It looks like maybe only one relevant one, K, so I should take a look at which one that is. ANSI escape codes. Let's see. K is erases part of the line. Oh, okay. So let's say that we'll also do that. Erase, implement, erase, and line. Because that seems easy. And hopefully if we do those two things, less and so our like git log and stuff, like anything that uses a pager will like hopefully work reasonably okay. I don't actually know if that's how this is gonna end up, but that's the goal. That's the goal. So that's kind of the goal for the day. Intro done. It was already flagged as done by mistake, but that's okay. And let's just jump into trying to create a canvas to work with. So this is probably gonna live in like the terminal emulator stuff. The way we have it like architected right now is there's like GUI, and then like terminal emulator. And the idea is that this guy is right now backed by like eGUI, but I have a suspicion in the future I might want to like implement something like tmux or something. So we might have like a terminal GUI, and we might have like, say you wanted to show it in the web, you might have like a web GUI, right? All of these guys should be able to like use the same backing terminal emulator that actually like tracks all of the things about a terminal. Like, you know, he spawns bash and he sets the cursor, like he keeps track of the cursor position, he keeps track of like what data is being modified when you move the cursor around and rewrite stuff. Like he's doing all of the actual work, and this is just for display. So this like canvas is going to live in this guy. Probably. And right now he just has his like buffer of data here, and that's it. So I guess what we're going to do is just going to replace this guy with something, right? We're going to say like struct canvas, we will call him. And he's going to, maybe for now, just be backed by a vec u8. Not really sure if that's how we're going to keep it, but that might be what makes sense for now. And maybe we start by just replacing buff with canvas and just kind of seeing what needs to get done there. And then once we have the thing in the right place, then we can start like iterating and improving. So we make this guy, he has a function new that's going to generate a canvas, and he's just going to be like a canvas with an empty buffer. So he's going to be buff is vec new. And then here we replace vec with canvas, and this is, we'll rename him buff, or to, sorry, we'll rename him from buff to canvas in a minute. Insert data at position seems reasonable. This is taking in, so this API currently is saying we are going to take the current cursor position, find the like offset in bytes. This like output start is like an offset in bytes that is where we're going to write into the buffer. And so I guess here we would, instead of inserting at the like offset, we kind of want the API to take in the cursor position probably. So we're going to maybe say like insert data, and the position is a cursor state. Let's see. Let's think about this. Okay, so a question here is, should the canvas own the tracking of like format data? So like when somebody says, I want this to be read, is that this guy's job to keep track of that? And let's try to think this through a little bit. So what happens? I go to a specific position. I say, put these characters here, and I want them to be red. I don't think, I think that being external is fine. The color tracker is sitting outside. They're both getting the same cursor position, and if they're both working correctly, then there's no tying together that has to be done other than position. So I think that's okay. So instead of taking a whole cursor state here, maybe we'll just say we'll take in a insert data x pause u size y pause u size and data. Okay, seems reasonable. And where we were currently saying insert data position, we will now just say self buff insert data. I think is that not? Yeah, function insert data. I don't know why my autocomplete isn't working, but that's fine. And we'll say self.cursor pause x self.cursor pause y and the data. And for now, he's just going to do this same thing, where he's going to say cursor to buffer position. He's going to, who now doesn't take in a cursor state, he takes in a x pause and y pause as u sizes. U size, y pause is a u size. Okay. And so that means that this guy just has to be called y pause and x pause. Okay. Okay, which means that here we have to pass in x pause and y pause. And we need to pass in self here. Probably mutably. Mutable self. Cool. And that's it for now. Then we change this API, so... Oh, this is interesting. What is happening here? Push range. Ah! So the color tracker right now is tracking relative to buffer position, not cursor position. Which is kind of interesting. Which kind of makes... should the start and end be in cursor space? In XY? No. Probably not. Okay. Let's just leave this for now, and we will kind of make a mental note to come back to this, because it seems kind of tricky. But we'll just leave this output start in here as well. And self.cursor pause x and self cursor pause y. Okay. I'm not really sure about this. We'll have to see. So maybe we'll actually put a note here and say, where do we want to put this? Fix me. Should start end be in a different coordinate space. I think probably what's going to end up happening is I'm going to end up making my canvas. And he's probably just going to be have some sort of fixed width and height. Probably. That seems reasonable. And then you could still consider this a linear offset into this buffer if you consider the canvas the whole thing. Except for the fact that if this has an early new line, and we just don't want to print the rest of this stuff, this effectively turns into this, then these offsets are all going to get adjusted. So it seems likely that this formatting stuff is going to end up living inside the canvas. That seems pretty likely at this point, but we won't get there right now. Let's start small and work our way up. Okay. So we have to fix this, self.cursor pause y, and the same. This is not a borrow anymore. And ooh, we don't like this. So clear forwards is no longer acting directly on the buffer, but is acting on the canvas. And so that canvas should have an API to clear, I guess. Function clear forwards. And he's just going to take in a position. And he's going to delete everything past that position. And so maybe right now we're going to write unimplemented. And then we can just say self buff clear forwards from self cursor pause x self cursor pause y. I don't know. We'll see. It will become clear quickly how much we need to fix. Cursor to buffer position needs to take in the buffer. I guess for now, we will just write buff because I'm not really... We'll like look at the private members of this guy because we're going to assume that this isn't going to stay this way. And so I'm not really too worried about the like leaky abstraction. At this exact second... You know, we don't really handle this clear backwards correctly at all. I'm just gonna like fucking delete it. There's no reason to handle this. Clear backwards. Because like we don't really understand what it's supposed to do right now, so I'm just gonna delete it. Yeah. Yep. Okay, clear backwards, just like fuck this. Okay. Because I don't like it. I don't like it. And we'll just say clear all here. And this is a pretty easy implementation. This is function clear all. And at this point in time, this clear just does self buff clear. Easy. All right. And does that compile? Close. Close, close, close. 421. For now, we will just do this. We will just release the internal buffer to the world. And now we're in a state where it compiles. We can rename this buff to canvas. There we go. Cool, 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 cool. So if we just this, easy, cargo run. And if we do like a simple little test where we just run like ls clear, clear, not implemented. Ooh. Clear forwards, not implemented. Okay, so for now, we're just going to take the cursor position, and then we're going to say buff self buff dot resize output start. And this is an output start. This is like del start. Maybe not resize. Maybe we'll say truncate. There you go. There we go. And this needs, this just wants to be called data. And now, hopefully, our like simple test of just doing like an ls and clear will probably work. We can do like pager equals cat get log dash n1. Okay, colors look like they're working. Clear works great. Ls great. Okay, we're chilling. We're chilling. So, what is next? What is next? So. The trick here is, I guess, we want to make sure that writing to an arbitrary location makes, like, works. So if we do cargo run, and we do, give it a sec. I don't know why that's taking so long. If we do, like, echo-e, you know, our, like, little escape code, open brace, go to column 20G, G for go to column, for G for go to column. Yeah, sure. If we write this, we want that to not crash. So it seems like there's probably a simple test you can write for this function. Test write past end of buffer. And we can just say that we have a terminal emulator. Let emulator is equal to terminal emulator. Well, maybe we can just, we only really have to test the canvas here. So we'll make a canvas and we'll say canvas insert data. And we just want to insert it at like 21, and we want to write like ASDF. Maybe it's okay here to just do the whole terminal emulator. That's like kind of like a more realistic test. I'm kind of okay with testing the higher level interface here. So we can say terminal. Oh, but the terminal emulator does create like a bash instance stuff, and I don't really know how to deal with that. Okay, sure. Canvas it is. Canvas it is. Okay. Sure. Sure. Okay. Oops, I want to cargo test. What am I doing? So this should be canvas. I don't know why I was like high there. Cargo test. And so this should panic. Perfect. So that doesn't work. And so now we just have to worry about fixing this test. We can ignore the like greater info of the world, and we can just say, okay, what happens when somebody inserts at a position that we do not currently have in our buffer? And so I think probably something that we're going to want to do is we're going to want like a known size of our window. Maybe we'll track those as width and height. And maybe we construct this thing with a width and height. Okay. Width, height. And now we have to fix the people that make this guy. So canvas new. He's going to take in, well, let's just like do 800 by 60 for now, and we'll fix this later and say fix me should be provided by GUI. Provided by GUI or updated. Also, 800 by 600 is way too big. That's in pixels, right? Let's say 80 characters wide. And like, I think somebody in my chat the other day said Bash has like a default size that it expects. Bash default terminal size. 80 by 24. So maybe we'll just match Bash there. Initial size matches Bash default. Does it make sense to pre-allocate the buff inside the canvas using the width and height information? I'm not sure. I have to think about this a little bit because I don't know if I want. I think the buffer is different, right? Because if I'm going to provide this buffer to like the GUI framework, and I have like ASDF \n, ASD \n. These \n's need to be in the buffer, but they're like zero. They don't actually count towards the like characters that we can fit in the screen, right? Same if we do if the thing says like \r\n, it's like, well, really we only need to care about the ASDFs in this case. But there's like the byte to position mapping isn't like constant. It's not like consistent. So I think no. I think. We'll see. What probably makes sense to me is okay, so like what do we expect to happen here? When we insert data, let's say data is longer than row. Or data, like say you want to like insert ASDF at like width -1. This should end up with something that looks like ASDF. But like, do we want to know about that? I guess we do, because if then we want to insert something at height 1 width 0, we need to know we have to overwrite the S. So like the wrapping info weirdly is not handled by like the UI that we're writing to, but it's handled by us internally. I guess. I think it has to be. Well, maybe it doesn't. Say we just wrote ASDF into the buffer. Right? We just did a little like, our buffer, all he has is we insert a bunch of spaces, ASDF. But we know that our width should match the GUI width, and so the GUI should wrap this the way we expect. I guess saying should is pretty strong here, right? Like, you're kind of like opening yourself up to problems if there's any slight mismatch between the UI and our internal state. I guess it makes more sense for us to handle the wrapping. That makes more sense to me. And so then the question becomes, okay, do we inject a new line here? And I think the answer to that's no. I think that's stupid. Because if we're not trusting the UI framework to handle the wrapping for us, then what we should do is we should just tell the UI framework, don't fucking wrap, please, never wrap. You're bad at it. Well, he's not bad at it, but whatever. And we should provide individual rows, I guess. That seems reasonable. Which means that maybe you're right, pre-allocating a buffer inside the canvas does make sense. Yeah, I think I'm okay with that. If we assume that each character displayed by a terminal is like one valid character, it would be interesting to know how other terminal emulators handle like UTF-8 characters that are like multi-bytes width. But for now, let's just assume. Assuming for now, I won't put this note here, but we're going to assume for now that there is a one-to-one mapping between byte and character. Not true, right? But maybe true enough for a terminal emulator. And so we can just say that the buff with capacity, maybe not with capacity. Let's just pre-allocate it. We can just fill it with like what goes in here? Spaces? Nothing? Let's think. Yeah, I don't know what it should be filled with. I guess probably a space. Like, it makes sense. Okay. Oh, this is should be a semicolon here. Okay. And that makes everything else really easy. Because cursor to buffer position is as simple as I guess maybe we'll move cursor to buffer position into a member function of this guy. So we'll say function cursor to buffer position. I'm not really sure if it makes sense right now, but that's fine. We'll figure it out. I don't know if everybody else is ever going to use this, or if they should just, but maybe they will. I don't know. We'll see. And so here we're just gonna say y pause times self.width plus x pause, and then maybe we do a little assert x pause is less than self.width and y pause less than self.height. Assert, yeah, that seems fine. And now this returns usize. And now instead of this, we're going to be using self cursor to buffer position. Okay. And let's rejig this to self insert data at position. Maybe I guess insert data at position does everything for us. And so we say x pause, y pause, data. Okay. So what's that look like? I guess that is just this function. Like, why am I, like, what? Okay. Insert data at position. So what did we do before? Okay, so we're assuming that data is writable. We are... oh. What happens when we get to the end of the buffer? There's going to be some scrollback issues, which we're going to have to handle. But otherwise, let's just, okay, we'll ignore the scrollback case for a second, where, like, you write to the end of the buffer and you want everybody else to move up. Before that, you just want to go to the position. So we'll say let buff pause equals self cursor to buffer pause, x pause, y pause. And you just write the data at that point. Yeah. So then we say buff data, or buff pause onwards to buff pause plus data length. You just copy it in. Which has obvious problems, right? What if the data is too long? And so I think what if the data is too long, actually, I think it should like evict stuff that's behind. Which kind of means that this is like, this buffer should be a circular buffer that evicts a line at a time. Right? Maybe? Maybe. Which seems like a kind of generic thing. So maybe we'll make a circular buffer. Who will be pretty simple. Well, I guess he's not a generic circular buffer, honestly. He's not really. So this is kind of like a specific circular buffer. So we'll say struct canvas buffer. Does it make sense for him to be like a new thing? Or do we just do it all inline? We might just do it all inline. Let's see what that looks like, and then we can decide if we need to split out the abstraction later. Okay. So, what do we have? We have our width, and I guess we just need our start, buff start. Yes. U size. And so his initial state is going to be 0. And we're just going to need to kind of make a more intelligent cursor to buffer pause now. Where this is now something crazy. This clear forwards, I think, oh, we'll have to handle this as well. Fix me. Update for circular buffer. Okay. So here we're going to look at the buff start. And we are going to add all of this. So we'll say let buff offset is equal to this. Or we'll call this logical offset, maybe. That seems reasonable. This is where how far into the buffer we want to write. But where that actually is in the buffer depends on the like where we how much we've circled in our circular buffer. Right, so the idea is that like we have buffer of shit, and we're kind of like saying that like we're setting the start to like this position, and so like 0 in the buffer should start here, and that means that just like when we start writing, when we wrap all the way around, we write boom 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 boom, and then we go like oh, time to write from the beginning. We write here bum 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 bum, and then we get to this dot, and then we say okay, well I want to write more shit, so I'm gonna move this dot forwards. And this is the new start, and so everything else, like everything, all of the data like doesn't move, but like where we start looking at it does. And so our buff pause is going to be self dot buff start plus logical offset modulo the buff size. And this needs to be like, we want the addition to happen before the modulo, and we need self buff up here. Okay. Seems reasonable. And so now we have some shit that we're writing, and we want to say, I guess we want to just keep writing in chunks. Yeah, until we'll say we have data that's like 5 times the length of our canvas. You could say I'm only going to write the last bit, but I imagine that when we implement scroll back, it will make more sense to do it this way. But I guess it's silly to like provision for stuff that you don't know what it's going to look like. But it's also simpler for me logically. So let's just start with the stupid case of we are writing way too much. And we can say, we can take the data. Okay, let's think about it. So we have buff pause that we're trying to write to, and we can only write up to buffer length. So I guess while data length is less than buff pause, well, it's greater than, sorry, buff pause subtracted from the buffer length. Yes, yes. We're going to make buff pause mutable so that we can modify it in iterations to loop. And we're also going to make data mutable so we can like say we've written some amount of data, we have some amount of data that we want to continue writing. We take data up until this amount. So we'll say like let to write is equal to this, or yeah, we'll this. Write length, we'll call it. And we'll say data up to write len is copied into the buffer at that point. So self.buff pause ... starting at buff pause onwards. Copy from slice. This should be buff. Yes, self.buff. Copy from slice. Data onward to at this amount. Boom. Copy this in. And then we just have to handle this last case where data dot. Oh, and then we have to update the data length. So data is equal to data write len onwards. Cool. And then here we also say buff pause is now 0. Okay, so now we just have to handle the last iteration. We might not have written the whole thing because we were only writing if the data length was too large. And so now we know that we can write from self buff pause onwards, where buff pause is guaranteed to be 0, I guess. So we'll just say up to data.length, copy from slice, data. And I think that's it. Maybe. And we can write fix me. Why write the first and iterations at all? Question mark. That seems like it would work. But we also have to move. Do we have to adjust the buffer start somewhere in here? Right? I guess at the end? Let's think about this. I'm missing something here. So we have like we have a buffer. A, B, C, D, E. And maybe we'll say up to F so that we can kind of write it as 2 lines like this. Now we come in here and we want to write, say we're here at the end of this. We want to write some more. So we immediately loop back to the beginning and we are no longer, so if we're at the end of we'll say we're at E, right? We're right here. If we write 2 bytes, we're going to write 1 at the end and then 1 at the beginning. So the first byte is going to go through this stuff, right? He's going to say, hey, my length was too long. And so I'm only going to write until I hit the end of the buffer. And then he's like, okay, and then I have some extra stuff to write here. And what we're missing here is that the stuff at the beginning needs to come after the stuff at the end logically. So we should actually write the buffer start is moved forwards data.len over width amount. Does that make sense? So if we write like 2 bytes here, we write 2 bytes here. We want to error on the side of too much here. So we're going to round this up. So data.len plus self.width. How do you do like a rounded up add in in like integer math again? You have like God, it's so hard. You have like 2 over 4 and you want this to go to 1. You want 1 over 4 to go to 1 and you want 4 over 4 to go to 1. You want all of these to go to 1. which means that you need to add 3. Yeah, that's it. Data len plus self.width minus 1 over self.width. And maybe, since that was fucking hard, we should do a roundup div. Roundup div. And we have numerator usize and denominator usize, and he's going to give back a usize. And he's just going to say num plus denom minus 1 over denom. And we can test that. Because we might as well. Test roundup div. Roundup div 1 4 should equal 1. Assert eq. And 3 4 should equal 1. 4 4 should equal 1. 0 4 should equal 0. Expected 3 arguments found 2. Oh, because this is supposed to be comma. Okay. And then here we say plus equals roundup div data.len width. Easy. Easy. Now I don't have to write a comment saying what I'm doing because it's fucking obvious because of a function name. Okay. And I guess we also have to clear anything other than that. So we should actually say that, like, let new start is equal to this. And then we say self buff start is self.buff, but from the current buff start to the new start is just going to be filled with spaces, I guess. Fill with space. Wow. It's kind of nice when you just like assume an API will exist and it does. That's kind of sick. Except it doesn't work the way I thought it would, so that's also super cool. Is it just fill? Fill. There we go. And then we adjust and then we copy in. But then we're always writing at the beginning of the buffer, which seems kind of fucked up. Oh, but that's because buff pause is always 0. I think that's right. I don't know. Something about this doesn't feel right to me. I feel like we've missed some cases. But I guess there's an easy way to find out, and it's by testing it. First of all, does this still compile right now? It does. Okay. And so we can just do something like function get data or toString. Sure. Yeah, why not? Why not? And what happens here? We take I guess maybe we want this to be, oh yeah, it's fine. We'll say mute output is a new vector, which maybe you might be able to dodge this, to be honest. Like, maybe it makes sense to say more output. And we can do the same thing that like the vec deque API does, which says like, hey, we have 2 vectors and they're not necessarily contiguous. In fact, I think the vec deque is probably a circular buffer, to be honest. And you can do something like, we're going to give you 2 slices of data because there are 2 contiguous chunks from self.buff, the buff start, onwards. And the second half is self buff up to buff start. There we go. And then we can say, if you want to stitch those together externally, go for it. But we're not going to make you stitch them together externally into like one contiguous vec if you don't want to. Right? Do whatever the fuck you want. You know? That seems reasonable. And so now we can go into a test. And I guess first we'll see if that test fails right now, which it won't, because it won't run at all, because we need to make a like, you know, 80 by 24 canvas. And that doesn't crash anymore. And now we just want to actually make sure that what we wrote is reasonable. So we can say, can this get output, let AB is equal to this, and maybe we will treat it contiguously, because that will make our lives easier. So we'll say let mute output merged is equal to vec new, and output merged dot extend from slice A and B. And now we assume that this should be assert equal output merged, and I guess it's going to be like we're going to have like 20 spaces, 19 spaces, then ASDF, then a bunch more spaces. So what the expected output is something like is a vector of spaces that is 80 times 24 long, and the expected output from 20 to 24 is equal to ASDF. And so they're going to say assert equal expected output and output merged. He doesn't like that because I need to do this. No, I see. I need to do copy from slice. Of course. Okay. So assertion left equals right failed. Cool, because they just inserted the data at the very fucking start. It looks like. Right? They just kind of stuck it here. Oh, because buff pause isn't guaranteed to be 0 in this case, of course. Now it's making sense. So this should be buff pause here. And do we guarantee a movement of the thing now? No, we don't. Because we are not, fuck. So we only move the buffer start if the length was too long. So we can say, if this, we want to do it once. Maybe. Something about this doesn't feel right. Something about this is wrong. So in the case where we are writing, I guess we can kind of just turn off our brains and just start with the simplest thing and just continuously test the next case. And then we just don't have to think. And love that. So we'll just never update buff start. And right, like now this test should pass. We should end up with the characters written at the right offset. We don't, because slice index 100 slice index starts at 100 but ends at 4 at 330. Hello. Starts at buff pause plus data length. There we go. Okay, so this doesn't work, but it does look like just a off by something error. Probably because these guys are, I actually just wrote, it's probably correct actually, I just wrote the wrong thing. So I wrote to 21, I meant to write to 20. Because it's 0 indexed, of course. Because who in the world would, okay, so that passes now. And now we can test like some wrapping logic. So we want one test that will test test wrapping logic, and then we're gonna want to test. I guess we want test canvas wrapping logic to know what the fuck this is. Canvas wrapping, and this should be test canvas represent a buffer, and then we also want one that's like, not just the wrapping, but like test extremely large buffer rate. Love that. Okay, so the wrapping logic. Let's say that we have a canvas of 8024. And say we want to write ASDF to 2379. 78? 78. What we expect to see is the A make it in here at the last line, 78. The S to make it as well. So we kind of expect like expected output expected output.len -2 onwards should get the AS. And expected output 0 to 2 should get the DF. I think. And this won't work, obviously. Output merge. And maybe our canvases are too big, to be honest. Because when these things fail, it's like a disaster. So let's just make them like 10 by 10, right? Because we can assume that any logic will continue working. And we can say that this offset should be like 5, right? And this should be 5 to 9. And we'll do the same thing here. We'll do like a little 10 by 10. And we'll insert data at, instead of 2378, it's going to be 9, 7. And then we have here, this could be even fucking smaller, right? This could be like 4 by 4. Who cares? Could be 4 by 2. Yeah. And so we're going to insert data at 2, 1. And we're going to assume that this should be a 4 by 2. And we expected output length -2, dot dot is copied from AS, and then 0 to that. Yeah, all that is still right. Output merged does not exist here, so we have to do this. Which maybe is indicating that should be split into a function of some form. But fuck it. Oh, this is one of those things where in Rust you're like, this should work, but it doesn't. Where extracting the length of a buffer as part of the indexing for a mutable buffer results in 2 mutable borrows. You have to like extract the length first, which is kind of silly, but that's fine. Oopsies. I want to do select till dot, do that twice, paste, and then say start. Okay. So that doesn't work. Test canvas wrapping logic, range and index 10 out of range for slice of length 8 at line 317. Okay. Right, so this is obviously not going to work anymore. So now we can say, while self.buff start, yes. Oh, we don't need to do, we have no buff start here. This while loop was correct before, I think. So we can write that. Oh, hold on. This test is wrong, by the way. Our expected output, we're testing the wrap here, but we don't actually want to do that. What we should be expecting is that, let's make it 3 lines tall. Oh, also that 2 was wrong. So 3 lines tall. We'll write to the second line. At the second, I don't know why. I've got a lot of this was wrong. So we do this thing, blah blah blah, and our expected output is full of spaces, but 4 by 3, and the start is going to be so we have space, 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 space. 1, 2, 3, 4. And we are expecting that we write df here, and then it gets cycled down into AS. That's what we want. That is the fucking key here. So this is 4, 5, 6, 7. 7 to 9, we want this. And we want, wait, is that right? No. 0, 1, 2, 3, 4, 5, 6. 6 to 7. And then 8 to 9. 6 to 7. That's only one. 6 to 8. 8 to 10. There we go. That's what we expect. And that certainly won't work. Okay. So let's go back to this version where we won't worry about buff pause or the buff start at all. But we will just see if we write what we had there, we should see, okay, left is what we expected. No. Which one's left and which one's right? Right is what we expected. No, here. Right is what we expected. Left is what we got. So what we got was half of it at the beginning of the buffer, half at the end, which makes sense. We were expecting it to look more like this. Okay, so now we just have to adjust the buffer start according to that. And I wonder if this roundup logic was right. It didn't feel right. And we know it's not right because the other test fails. So we know we can't just do that unconditionally. But we do want to say that for each line we write after this. Maybe we'll special case the simple case. If data.len is less than this, less than or equal to, we will just do the simple copy. Data like this. And we return. Otherwise, now we know that it's too long, and so now we can do this buffer start management automatically. And we can even short circuit. No, I'm not really sure we can short circuit, so we'll just read it right like this. Okay. Okay, so we have a buffer, and we fill the start to the new start with empty. We update the start. Maybe that was right. We'll see. Correct test. Okay, so the left, still not good. It does look like it moved slightly differently. This has to be times the width. Because we only moved one back, I think. Before we had 2 at the beginning, 2 at the end. Now we have 1 at the beginning, but we should have. It's because we tried to shift left by 1 row, but you only shifted left by 1 character, I think. So we just need to multiply the new start by round up div data length over self width. That's how many rows times width plus the current start. There we go. Still no? Source slice length 4 does not match destination slice length 95 at 318. Right, this is buff pause, so buff pause plus data len. There we go. And now both those tests are working. And now we just have to handle this test extremely large buffer. So we can kind of do this same thing where we write like, maybe we'll just fill this with zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this should result in the same answer that we got here. Okay. And it doesn't. Oh, because it should be zeros, not spaces. Everything should be zeros. Oh, right. Okay, so it looks like it's interesting. So what's actually happening looks correct because we insert a bunch of zeros, we overwrite the line, and then the line should be padded with spaces at the end. So this should be df space space. Okay, that's working. So it looks like in this case we get we end up with 0 0 0 0 AS DF space space, which makes sense. So even though we wrote a bunch of zeros, the spaces take precedence on the new line. And then it would be kind of interesting to see if then we write maybe 1 1 1. That should end up being 1 1 1 like this. So we can just say the expected output is byte string 00ASDF111 space space space. And I'm curious to see if that is going to work. If like the second line rollover is correct. Hell yeah, baby. That's sick. Okay. Okay, so we've got like rollover working reasonably well. And now, unfortunately, we actually have to handle new lines in here. So maybe we should, this should be test canvas. And so now we have to test canvas write with new lines. And so let's take a canvas that is kind of fat, maybe. So maybe we'll make him like 10 wide and 3 tall, and we're just going to write out like AS new line DF. And maybe we'll prime it with zeros. That seems kind of reasonable because if we fill the buffer with zeros, we should make sure that this \n results in empty space filling on top. Maybe not. If we new line, are we supposed to clear everything following? All the stuff following should already be cleared, so maybe that's fine. We just won't have to worry about that. We can say canvas dot insert data. Oh, we already did that, and so we just do the same thing. We expect some output that is going to be AS followed by 1, 2, 3, 4, 5, 6, 7, 8 DF. Is that what we expect? Shouldn't the output, does the output know about new lines? It has no idea about new lines right now, which kind of means that you actually want like a line iterator when you get the output. You almost want like a function output gives back a like impl iterator item equals u8 slice, where each chunk is a line. And so then we can say self buff start. We kind of want like let num lines is equal to height. Then we start at self buff start. And I guess we say what? 0 to num lines, map each index to a range that is like I times the width plus the buffer start modulo modulo the buffer length. And this is actually now not just This is the buffer starts. We'll say let buff start. In fact, we should just say cursor to buff pause. Cursor to buff pause for x pause 0, y pause I. Yeah, okay. Let buff pause equal this, and then we just return self buff from buff pause to self buff pause. Sorry, buff pause plus self width. So this will give us a line of time. And now, all of these places where we're doing output, we need to just say can you automatic, is there like a function to take in an iterator of slices and just append them to a vector? Because that would make this simple. Vector rust. What does he have on him? What does he have? Like extend from slice. No, like extend from iter. Isn't there? I swear there's like an extend that takes in an iterator already. What do I want to do? I just want to like, I have like an iterator of slices. I have like canvas.output is going to give me an iterator of U8s, of U8 slices. And I was kind of hoping that there was just like some function that existed where I could say like output merged dot extend from canvas.output or something. I was hoping that existed. Oh, which maybe it does. It's not like crying. I wonder if that works. Let's try it. Our test. Right. Everybody else isn't compiling because I just fucked it up, but let's see. Yeah, I want to combine them all into a single slice, exactly. Oh, I guess I just collect them. I'm a fucking, like, can I just do, like, canvas, output, collect, into vec u8, and maybe that'll do it for me. Let output merged is equal to this. I think that's right. No, because he can't make those, but you could do something clever, like flatten them. From iterator, and then I have to do, like, copied. Yeah. Oh, we're so close. Flatten, copied afterwards. Yeah, that'll do it. That'll do it. Which is a disaster of an iterator chain, but it's fine. And that passes, which is good. Okay, so now let's maybe make a little helper function. It's like function canvas output to vec. And he's going to take in maybe a canvas. He's going to return a vec u8. And then we can just take this shit show. Womp. Hey, do you work at Fang? No, I do not. I'm currently not working anywhere. By choice. To do this instead. Which is maybe stupid, but fun for me for now. Yes. It's life. So if you're looking for somebody who can tell you how to interview at Fang and get in, I don't have much of a help for you there. Although I do know people who've done it, and it's just a lot of leak code. Studying was what it looked like they did, but who knows if that's like selection bias. Maybe the people who are studying leak code that I know already were Fang hireable even without it. What do I know? I know nothing. All right. Close. Except that he needs to be mutable, which is just unsure, I think. I think we can just go back to this function and say, you don't need mute. All right. That seems like it's working. And now the rest, we can just apply the same shit. Canvas output to vec. Canvas output to vec. Canvas. Canvas. And the same here. Canvas output to vec. Canvas. Canvas output to vec. Why? Similar name, canavs. Oh, I've spelled canvas wrong. God damn it. So I search for this, delete to s, and type canvas correctly. There we go. Tests are still chilling, and so just we gotta fix this last one. Test canvas right with new lines, which I think is not correct right now. Oh. We actually want to splice in new lines when we collect these, I guess. That was the whole point. So can you like flatten with a separator? Maybe we'll just do this the long way. We'll just do it the long way. Fuck it. Let mute output is equal to vec, you know, the output. We say for, or let, yeah, whatever, for line and output. You'll need iter tools for that. Fuck that. I'll just write a function. Output dot extend line output dot push a new line. Yep. And return output. Iter tools is good though. Yeah, I'm sure that they are. But you know, we have some heavy not invented here going on here. The syndrome is strong with us, so you know. It is how it is. So this is now going to be what? With the wrapping logic, the expected output is going to be more like... Are you just adding /n's at the end? Yeah, of each line. Which is fine. I mean, well, the function was simple. I don't know. It's not. It doesn't really matter. Doesn't really matter. So this is gonna be a byte string of. What do we expect on this one? Canvas wrapping. So we expect 1, 2, 3, 4 new line. 1, 2 AS new line DF space is the expected output here. I think. And then on this one, the expected output is 0, 0 AS new line DF 1, 1 new line 1 onwards. And here we expect we expect 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters, then a new line, then a DF. Okay. I don't know if all of these are gonna pass now or not. We kind of fucked up at line 709. Where we are still using the old way, so this just needs to be canvas, output to vec, canvas. And the extend line, he doesn't like that because it's not an iterator. Sad. Sad, sad, sad. This needs to be a vec u8, I guess. He's too stupid to figure that out. Method not found in u8. Oh, I'm an idiot. This should be canvas dot output like this. And then this extend will work. I've seen a way to do that with chain. Oh yeah, I bet that makes sense, where there's like a way to chain on the inside. Okay, so all of these are fucking wrong now. Because 701. My expected output was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, maybe he needs a new line here as well. At the end. Yeah, that's it. All of these guys need a trailing new line. We're close. 710, 683. 683, what's this one? 10, 10. Canvas right past end of buffer. What the fuck? This isn't testing our right past the end of buffer at all. Is it? Oh, yeah, it is. It was the old end of buffer. Canvas right where no right into empty space. We'll call it. And maybe we'll make this buffer smaller so that my expected string at the end isn't as crazy. So we'll just make this like 10, 1. And the expected output is now going to be 1, 2, 3, 4, ASDF, 5, 6, 7, 8, space, new line, I think. 682, not quite. We were maybe off by 1. 1, 2, 3, 4, 5. Yeah. That is reasonable. And the last thing, the last one, 709. So he got a bunch of spaces, then a new line, then a bunch of spaces, then a new line, then some stuff. And we expected not that. Right, because again, this is just obviously wrong. What am I fucking high? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope. It's they expect 2, 2. Oh yeah, that's right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then a new line. 1, 2, 3, 4, 5, 6, 7, 8, AS, new line. No. 10 things. So if we write to 2, 2, yeah. It's like this. We expect a bunch of spaces, then a new line. That seems reasonable. And we just write spaces anytime where I have to, and we're a little bit off still. Because are there 2 lines before this? Hold on. So this is 10 wide. 10 wide. We are inserting at 2, 2. Does this make sense? Let's see. So we are inserting at the second line, ASDF. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are inserting at the second line, position 2. So that's here, 0, 1, 2. And then this rolls around and becomes DF. Okay. So this should be like this. But otherwise, that's correct, I think. Oh, this needs a bunch of new lines at the end as well. A bunch of space to a new line as well. And this can't have these new line leaders like this. It's just really like this. And we lost the 2 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 new line. Okay. I think that's right. I think that's what I expect at least. And I don't know if our code is actually doing that. So we expected 2 spaces, then a 9, 7. Yeah, so the problem here is that our code is not injecting spaces out when it sees an early new line, which is what we were trying to test before anyways. So I think we are chilling. I think this is the right test. Okay. So what we need to do is when we see a new line, just jump down to the next thing, I guess. So we almost want to like split the data by new lines. Is that true? Whose responsibility should the new line splitting be? Whose responsibility? I guess ours. That makes sense to me. The canvas can split it. So he gets some data, and he goes, hey, it has an early new line. Split. And we can split at new lines. And maybe we do for line in lines, just everything we were doing before. Just instead of data, we replace it with line. And instead of return, we continue. Okay. And this is like this. Split at this function, and he doesn't like this guy here, which is reasonable, so we just make this mutable. And I think that that might do something. So what happened here? We have a line of spaces, great. Another line of spaces, weird. But then we do have a new line. Then we have the 102, 100, 102 followed by a bunch of spaces and then a new line, which is also great. So we just don't write the last line. And is that because here, if the thing fits, we didn't handle the buffer start update correctly? That's kind of like all of this stuff still has to happen up here as well. Oh, this buff pause thing needs to be updated here, maybe? No, because the XY pause and Y pause are still good here. This doesn't work just like using what we had before. So for each line, let's maybe think with our heads. With our brains a little bit. So if the line is too short, we just put it in there. No updating of buff start. I think that's fair. I think that's fine. Then, for this line, if the line's uber long, we do all this writing stuff. Well, not even uber long. Even if it's just like at the end of the buffer. We adjust the line, and then we write the rest of the line down here. So I guess just nowhere are we handling the fact we're just not handling the fact that we should see a new line. And so I would like to see, is there like a split, like inclusive? Yeah, nice. And he just continues at the end, and we can just say, if line ends with a new line, what do we do? Here, I guess we set the buff position. Buff pause plus equals self dot width, but only after we write it. So like here, ends with, he doesn't like that. Needle takes in a slice. Oh, so it's a byte string like this. And then we also have to do that down here, I think. But we don't want to write the slash ends. So we actually want to do something like let line is equal to line until the backslash n. So if line dot ends with a backslash n, the line is equal to line of everything in the length -1. And has newline is true, I guess. Or let mute should has newline. It's false, and then it's true here. I don't know. Okay, and then if there's a new line, we advance the buffer position, which we should have done anyways. Self buff pause, because now we're only doing this at a line. So self buff pause plus equals line len, not self buff pause, just the buff pause. And if there's a new line, the buffer position is set by the new line. If the buff pause, if there's no new line, we do that, but if there is, we do. If we have a new line, after we write all that stuff, we jump to the next line. Yeah. So we say, we need to like round it up to the next one. So we can say buff pause plus equals like buff pause percent width. So if the width is 10 and we're at position 0, we get 0. And so you want to do like 10 minus this. Self.width minus this. So if the buff pause is 1, we get 1 and we add 9 to get back to 0. Yeah, I think that's right. I think that's right. And then probably we just have to do this down here as well. I guess. I don't know. We'll see. All right. The test passes. Is that sane? Who knows? But it looks okay. What we have to do now is we have to try maybe writing something that is extremely long. We are covering the no, we're not covering the case where like the first line like wraps and then there's a new line after something. So we can try something like we start at position 8 and then we write AS DF 1 2 3 4 or something. Then a new line, then like 5 6 7 8. And it's like, what the fuck do we expect to happen here? We expect that we started at AS, then we should get DF 1 2 3 4, then spaces to a new line, then we should wrap again, and we should get 5 6 7 8. 1 2 3 4 5 6 new line or something. Is that right? 1 2 3 4 5 6 7 8 9 10. Yep. Okay. I think that's what I expect in this case. Except this should be spaces. So we should have 0 1 2 3 4 5 6 7 8. 2 characters, a new line, DF 1 2 3 4, then a bunch of spaces. So it should go at 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then a new line, and 5, 6, 7, 8. Okay. That is what I expect. And that doesn't pass. Which is sick. So what do we get instead? We get... It would be nice to print this better. Right? Seeing like 53, 54, 55, 56. It's like, what is that? I guess we can kind of like derive it based off of what we expected. So that's the 5, 6, 7, 8 here. And so that's getting set at the beginning of the new line. Probably because if we put an early new line, it's not updating the buffer start. Right, we were wrapping the buffer position. Oh, we shouldn't be doing this here, actually. This has new line is wrong. Yeah, we shouldn't be doing this here. I wonder if that changes anything. I can't imagine that fixes it. No, it didn't. It's something like here, the new start is now no longer just based off of the line length. The line length is different based off of if there's a new line or not. So we can say like line length is equal to, if there's a new line, it's like one thing. It's the line length padded to match the width. So add length for width, and we'll take in the line length and the width. Otherwise, it is just line len. Okay, and now we take the line length here. Everywhere we use line length below here, it gets updated. Now we don't have to worry about this. And now we have to implement pad length for width. Function pad length for width, and we have len usize width usize returns a usize. But we also need to know where we started. So we have start usize, len usize, and width usize. Okay, so start plus len. We take width and we modulo this. We modulo start length by width. Okay. Yes. Yes. So let left cars is equal to this. Yes. Yes. And then we say, or we'll say like written cars. Then we need to basically increase this until this modulo is 0. So we say width minus written cars. So this is going to be some number between, like, say there's like 0, 0 and 0. This comes back to 0, and we need to add 10 minus, or width minus this. The other place I did this, by the way, that is wrong, I think. Because it'll become, if the length is 0, it should be 0, not the width. Where did I do that before? Where buff start plus logical, no. There's only 2% in the whole file, so I must have deleted it. I guess. It's no longer relevant. So we kind of want to do width minus this modulo width, like, to get it back into 0 to 10. That can't be right. This has to simplify, right? Width minus width is just 0. So this is just written characters. Am I high? So if I have 0, like 2, and width is 10, I need to add 8. So that is 10 minus 2 mod 10. Okay? And all of this also mod 10. Which means that I need to do width minus written cars percent width mod width. I guess. And I guess because I'm really unconfident, test pad len for width. And we say pad length for width. We are starting at 2 and we're writing 4 and our width is 10. We should be padding 4. And, if we write 8, we should pad 0. And if we write 0, we should pad 8. I don't know. Fuck it. It's cargo test. Pad length for width, so that's just not working because there is a remainder with a divisor of 0. So that is... oh, right, because I'm just an idiot. These should always be 10. And we should have been changing 4, 8, 0. Nope. 8, 2. We expect 4, 0. Oops. No padding. No padding if it lines up, and we expect 8 pad 0. There we go. Thank God. Which passes. Okay, so our padding is correct. And then we need to pad length for width here, blah, blah, blah. And it's still not doing the right thing. So why did I think that we had to change that again? Because we were not updating the new start correctly. I see. We weren't handling the wrapping correctly. So our function is... the first bit is lined up correctly. We are expecting the second line to have 97, 115, 32, 32, blah, blah, blah. So this is at line 733. So now we've kind of like broken our original test case that used to work. I see. So we get some shit, we get a new line. Okay. Okay, so we are inserting data here. Let's just comment out this guy. Oh, we don't have to comment that. Can we run only this function? We can say like cargo test. There must be some way to like say I only want to run one test. Exact? No. Filters. Yeah, so I just pass in the name of the test. I see. Which is just this. Cargo test. This. Cool. And then here we can start printing shit. And that'll help us. In some way. Okay. So we know it's related to this, right? If we go back to line len, I think that passes. Oh, we're failing at 735. Nope, still broken. Okay. So when we insert data, we split by line. For each line, we check if it has a new line. And if it does, we say don't print that, but we'll like remember the new line existed. Then they say if the line is too fucking long, we're going to copy some stuff in and reset the buffer pause to 0, which is wrong. This is wrong. Because we should... oh no, that's right. Because we're checking if it's to the end of the buffer. So if it is, then we set the buffer pause to 0. Here we increment the buffer pause. Here we increment the buffer pause. I guess we need to do the same. We need to use this like line length shit up here, probably pad line for width, and this buff pause has to be increased by line length. And okay. Here we say we went to the beginning and now our buff pause is 0. And we increase the buffer pause by the line length. Update the start. I'm not seeing it. Not seeing the problem. So how is it broken? On the left, we have two lines followed by 2 spaces 97115, 1 2 3 4 spaces 100 102 10. And what are we trying to get? We are trying to get it's just right. Okay, so we go to 2 2, the last line, and we write 2 characters and the new line. Okay. There are 3 lines. Yep. So we write here our 2 characters, then the new line. But then we try to write the following characters, the DF. They're ending up in some weird place over here. They should be ending up after the new line. But instead they're being moved by 1 2 3 4 5 6 7 8 9 10. Yeah, they're getting in like position 8 of this line, which is fucking weird. Which kind of indicates that the buff pause plus equals line length is wrong. So here we have a new line. We have a new line. We should be in this case. We should see print line, line is this. Yep. So we are getting, oops, I wanted to run just that one specific test for now. Although it is concerning that everything else is failing. Which is maybe like a bigger problem. So let's start with this one. So he's getting line length of 4, and the source slice length 2 does not match the destination slice length 4. So this needs to be line.len, not line len. Because even if we're trying to advance by that much, okay, great. Little oopsie there. We still are fucking up this guy, probably for the same reason. So cargo test this one. And he's saying range end index 20 out of range for slice length of 12. So this is at line 354. The line length is 19. Range index out of 20. Can we run with like backtrace? So this is at insert data line 354. Buff start to new start fills with B's. Fills with spaces. So when we fill with spaces, we are calculating something incorrectly. Is there something to do with this? Like here, we're saying while the line length is greater than the buffer, but we're not accounting for like the padded new line. So this has to be line len probably here. Maybe there's something fucked up with new lines here. But also this new line stuff shouldn't matter for this test case. We were just writing, there's no new lines being written here at all. So like, what have we fucked up? What have we fucked up? I'm missing it. So it has to do with, surely it's to do with this. We just do line here. we don't try to pad anything. We try to run this test. Oh, he still fails, which is interesting. Interesting. Maybe this has to do with like the line splitting we did. So we say for line, in each line. This is one long line, is this test case. He's inserting one long ass line. So this loop only runs once. He is saying he doesn't like that there is a out of bounds right at 354 here, because buff start to new start is too long. So new start is being rounded up round up div. Okay. So this is too big. But why is it too big? So we're at the buffer start and we're trying to say either we're going to go for, let's see, let's print line. Line len and width and new start. And I guess we also need to say current start. Old start is something that we will pass in here. And so we need to say the width is self.width and the old start is self.buff start. Okay. What the fuck is going on? What the fuck is going on? So you have a line length of 19. Yep. Width 4. K. Old start 0. K. New start 20. Does that make sense? We're passing in 19 characters. Our buffer length is only 12. And what are we writing here? We're writing 19 characters. Right, we already know that. The line length is 19. That's obvious. Okay. So we're trying to write 19 into 12, which means that this no, 19 is less than 12. So we should not go through this case because the line length is bigger than the length minus the buffer precision. And then this guy just isn't doing his job, I guess. Because we should have written the whole buffer one time with the first amount of shit that we could fit in. So the right length is the buffer length minus buffer pause. Yep. And we copy in everything up to the right length. This all makes sense to me. Can we maybe print line? Oh, because the line length isn't updated after this. So you almost want to like overwrite the line length every time we adjust the line. Okay. So now that should fix this, which this is getting very complex. I'm assuming that I'll be able to like reduce the complexity of the code later. And now the only thing that's not working is the actual new line handling, which is fine. That's fine. Okay. So we're in this case again where we write 2 lines of data, then what we expect for the first set, and then it's not wrapping correctly. We're expecting kind of like this chunk to get pushed back by a line when we insert this at the next one. But he's been inserted 8 characters in instead of 12, which is odd. Which kind of makes it seem like this padding is not working. And we can look at this. So we have line len 2. And we are crashing at 742. Not helpful. Oh, because we're not crashing. We just get to the wrong thing, right? So we're putting in AS, new line, DF. And what do we expect to see? Can we run only that test? test this test. And why are we seeing line length written twice? Time to sleep. Hope the rest of the coding goes well. Hey, thanks. Appreciate it. Have a good night. So here it's because we're writing 2 lines. Right, so we print the line length twice. The first line we get is 6 long, which I can't be right here, which is probably where the bug is coming in. Add length for width. Two, 4, 4. Ooh, maybe I'm just not using this right. This should be line len plus the pad. Which means that in all of these cases, we actually kind of want the length to be 10 no matter what. If our width is 10, no. We want these all to be 8, right? If we start at 2, the length of everything should be 8, whether or not, like, no matter the length of the thing inside. Ah, okay, so this just has to be len plus this. And I think then all that makes sense. Yep, okay, so that fixes that one test that was failing, this right with new lines. And now we can uncomment the second one and see if this one works. Woo! This is hard. This is hard. So let's comment out the first one so we can narrow in on the failure. And, okay, so we get a line length of 12. Then a line length of 4. What are we writing here? So we have 1, 2, 3, 4, 5, 6, 7, 8, and then a new line. Starting at 8. Right, so that makes sense that we're writing 2 bytes, then another 10. That's correct, because we need to pad this to basically like look like a full line. And then we get a line length of 4. Also seems right. And so what do we actually get out here? So we were expecting to see 53, 54, 55, 56 at the beginning of a line, but on the last line. And instead we were seeing it at the beginning of the first line. And so it looks like we just didn't wrap our lines correctly. So when we pushed this stuff in, he was supposed to go, oh, I need to update my starting point. Because, so we have like our, our buffer is like 10 wide. And we put some stuff like in here. 1, 2, 3, 4, like, if we write like 1, 2, 3, 4, the next thing is going to show up here, 5, 6, 7, 8, and it's supposed to write down like, oh, I want these to come in this order now. So the buffer start is supposed to be here, when before it was up here, before we wrote. And it's not doing that for some reason. So where would that be? Buff start handling. Might have to be done on each line now. So when we only update the buffer start when the line length is too long, buff pause here. So we probably just, in this case, now that we're like going line by line instead of handling the whole insert at once, we probably have to update this buff start. Let's see. I guess this feels like so convoluted. Everything in here feels like it could be simpler. So maybe let's like function insert line. And he's going to be inserted at a specific buffer position. Okay. And that's going to be essentially all of this code. So first we're going to check. What the fuck just happened? Yeah. First we check it as a line. Makes sense. We have a line length. Also makes sense. It is padded depending on the new line. This is all fine. Then we try to fill the buffer. Oh wait, if line length is less than the buff length, then we just short circuit, okay? So we've taken the line here as well. Like this. Oops, this should be a comma. And instead of continue here, we return. And do we need to update the wrapping here at all? Let's think about it. So this is going to return the new buffer pause. And that's fine. Do we need to update? Okay, so if we write a line here, we make it to the end, there's no wrapping around the edge. So if there's no wrapping around the edge, there is no update of the start position because there was no wrap. Okay. Everything is chill. Now this is if line dot len, which seems wrong. I think this should be line len. This should be the padded length. And so we should, like, to avoid confusion, we should call this padded line len. So here we only write like this if the padded line length, or maybe it's if the line fits, if the line fits where we're currently writing to, we write it. No, the padded line length is fine. Padded line length. So if the padded line length fits, nothing to worry about. But then if it doesn't, then there is something to worry about. And that's when we do this part. So this says, while the thing we have to write is greater than the buff length, I think this should be the padded length. No, maybe not. While the actual data that we're trying to copy in, without the new line, is too long, we update the line length, we copy the data in, great. Okay. This now needs to be said called padded. And line is equal to this. Line needs to be mutable. Okay. I don't see a problem here. So we copy data in. We reset the buffer size. We update the pad. Then we just do the stuff at the end. Okay. So nothing too crazy here. I'm less confused by being in a loop now, so we can just say self.insert line at the buff pause. And we need, yeah, it's just like this, and then buff pause equal this. All of this needs to say padded line length now. And I think I can cargo test just to make sure that everybody else is still running okay. I think that shouldn't have changed behavior at all, which didn't, okay. And so it is just the wrap not occurring. So what case are we in? Holy shit. The case we are in is we expect a wrap here. No, here. So we inserted ASDF. Here is our line. 1, 2, 3, 4, 5, 6, 7, 8. He doesn't fit. Great. It's when we start inserting 5, 6, 7, 8 that we should wrap? No, it's at the new line. We should update the wrap at the end of the first chunk. At the end of the first line. Okay. As far as I understand it at this point. So when we write the line, that's here. This is where that should be occurring. And for some reason, it's not. Cargo test. So we have line length 10, width 10, old start 0, new start 10. Great. What's the fucking problem? Oh, we're not getting that print for the first section though. Well, I'm actually not sure. Let's also print the actual line length. So we can do it like this. So the line length 6. Okay. So that is probably, we inserted 8 at position 8. We tried to insert 1, 2, 3, 4, 5, 6, 7, 8 characters. Probably the first 2 got truncated, and so now the line length is 6, and we're padding that to 10. And I wonder, maybe we can print the actual buffer. That might give us a clue, actually. So can we like print line here, just before we do any assertions? Let's just print out everything. And then we can at least see if like where the data ended up is correct. So we see that we inserted this at the very end. So we should see AS at the very end of the fucking buffer. So we should see AS, DF, 1, 2, 3, 4, a bunch of spaces. Yep. Then 5, 6, 7, 8, and a bunch of spaces. So the data in here is actually correct. It's just the new line, the position tracking that's not. Which means that probably here, if buff pause. Oh. This should be a less than. Because here we're saying, if the padded line length, if we end up with a buff pause that's at the very end, then that's okay. Which is not true. I think. I think that should be less than. And that did jack shit. Okay. I thought that was okay. Here, if the line length... Oh, here we're back at the case where the line length... This is not the padded length. This is only how much we want to copy. Then we get to the end and we say, oh, this is the remaining bit that we have to pad for the new line. That makes sense. Okay, I'm pretty sure that's fucking right. And I'm fucking missing something. I'm missing it. Is it something like if buff pause here? Well, let's print line, taking easy way out. Let's just kind of see if that happens. I think it does, probably. Taking easy way out, and let's say with what? With padded line length. Taking away easy way out with 4. And can we say... Maybe we put the buff pause and the buffer start as well. Or we know where the buffer start is. We'll say print the buff pause. Taking easy way out with buff pause 10. So that is when we're writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 5, 6, 7, 8 at the very end. It feels like it's something like when we write the padded length, it's like perfectly set, and we just don't update the start in that case for some reason. Old start 0, new start 10. Okay. So as far as we're concerned, we are starting on the second line in the buffer. And that's not what we want. We want to be starting at the third line in the buffer. So when is that supposed to happen? When are we supposed to push that? It must be when we inject the next, when we write the 5, 6, 7, 8, we know that we're writing it at a new spot. Every time we write, the start should move. Is that true? For every line we write, the buffer start should be the next one. Yeah, that makes sense to me. So if we're at like, if we're here, and we're, like, say this is like the physical buffer. And say we are writing, at the very beginning, we are writing ASDF here. Saying that the buffer start should be here is pretty reasonable. So it's almost like every time you write, you want to set the buffer start to the next thing, no matter what. That makes sense to me. So it's like this should just happen all the time. And do we fill all the time? We kind of only fill if we had... Well, yeah, we want to fill everything from where I currently am. Oh, because we want to clear the buffer before we set it as a start. I see. So here, if I wrote something, I want to say that, like, the buffer start is equal to this almost like unconditionally. And I guess saying that we clear out the old buffer where the buff start was before we move it also seems reasonable. So maybe that's just right. Maybe we cargo test this now and everything works. Hey man, just want to say I've been enjoying the series. You should write a computer next. Appreciate it. Yeah, it's a fun series. I'm having fun as well. So glad you are as well. What the fuck happened here? I broke right into empty space. Interesting. Oh, Wayland compositor on a computer. That makes more sense. I do think that would be fun at some point. Window Manager is on my list of things that I want to try. Definitely on there. Sorry, I'm not supposed to be setting this as buff start. I'm supposed to be setting this to the buffer position. Rounded up. So we're saying no matter what, we want this to be thing. And then if the new start is the old start, we just don't fill anything. Okay, that seems reasonable. Still fucking broken. I'm so... Ugh, God, I'm gonna lose my mind. I'm gonna lose it. I'm gonna lose it. So I don't really see why this is wrong. Let's think about this. So the new start, where I currently am, plus, I guess where I finished writing is more what I want. Oh, God. So when I write to the buffer, every time I write, I want to set the start to the next line. Reasonable. Fairly certain that's fucking reasonable. So here, I write to the buffer. Hell yeah. And we can just say that the new start is, well, let's make sure that this calculation is right. So we divide the length by the width, which just isn't right. This should be buff pause plus this guy. Round up div. So this is how much we wrote. And why are we doing this? I think that's wrong. the new start, we want like the current line is the buff pause after we wrote divided by width. Let new start is the current line plus 1, the next line. We just want to be the fucking next line. And this is times self.width again. Self.buff start is equal to new start. And we fill everything up until that point. Yeah, okay, let's try that. And it's fucking broken. Great. Great, great, great. And I think I'm just going to do the same thing down here. I think that's reasonable. And let's see if that falls over. That, like, fucked up everything. Which is pretty surprising. Oh, but maybe that's reasonable. Maybe my tests should fail if I'm moving the concept around. Because now, when I write ASDF at line 5, oh, fuck. Okay, this whole assumption is wrong. Because that's only if we were only ever appending to the end of the buffer. But that's just not fucking true. Okay, undo, 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 undo. Undo, 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 undo. So the concept of saying that the next line should always be the start is wrong. It's only when we're writing to the end? Oh, my head hurts, man. I'm pretty sure we're not far from the right answer, but I'm definitely in that state where it's like, I'm not getting it. I'm just not getting it. And so I think I want to take a break, and we're past the 2-hour mark. So I think I'm going to call it there for today. Frustrating. I wish I could have got there. But sometimes it just hurts, man. Sometimes it just hurts. That's okay. We'll be back at it tomorrow. Maybe I'll come up with fresh eyes and I won't feel so fucking stupid. If you like what you saw, I stream most days at around 1 or 2 o'clock Pacific time for around 1 or 2 hours. Right now we're working on this like terminal emulator, but you know, there's a lot of different topics that we've covered. We've kind of been like, we're trying to jump around, cover a variety of things. The goal trying to just be like, learn shit about shit, you know? So we've done like AI, operating systems, 3D graphics, Blender stuff, this maze on the right? We've done a variety of stuff. File system. And so yeah, I will be back at this tomorrow. If you're watching on YouTube, there should be a Twitch link in the YouTube description if you want to swing by and chat, whatever. And if you're watching on Twitch and you want to be like, oh, I missed a stream, but I want to see what happened, there's a VOD channel linked in the Twitch description. And there's also like a GitHub linked in the Twitch description where this code lives. And there's a Discord link there too if you want to get notifications about when I'm going to go live a little bit ahead of time and chat about shit offline. Otherwise, I think that's it. Thanks for watching, guys. Catch you on the next one. Bye!